Okay guys, so today we are starting lesson 8.3 in Pearson in the 7th grade book. Alright, our goal today is to be able to draw triangles when given information about their side lengths and angle measures. So side lengths and angle measures are going to be called conditions. So we're drawing triangles with given conditions. So if we look at this first example, it says students in woodshop class are measuring and cutting out a triangular base for a corner shelf, with sides measuring 6 inches, 8 inches, and 10 inches. How can you determine if all the students will cut out the same triangle? Alright, so right here, we'll see we have 3 triangles created with these required side lengths or conditions. Alright, it has a side of 6, 8, and 10. What you'll see is, no matter how we construct this triangle, if we use these side lengths, it's actually the same triangle every single time. Right? It doesn't matter if we turn it around or anything like that, it's still the same triangle. Okay? So, triangles with the same side lengths are the same shape and size, no matter how they are positioned. So in this case, all the students would cut out the same triangle. If we look at example 2, we get more of a reason behind why this is the case or when it's not the case. So, Steve gathers 3 pieces of wood from the scrap pile in the woodshop class. Can Steve make a triangle with these 3 pieces of wood? Explain. Well, we have 3 feet, 4 feet, and 8 feet. Now, as you see, if we draw this, these two sides aren't long enough to connect. Even if we laid them flat, well, this right here is 3 feet, and this is 4 feet, so that's not even as long as the base. So there would be a gap right here. What this leads us to know is if a triangle's 2 smallest sides do not add up to greater than the longest side, then we can't make the triangle. So even this one right here, we have a side length of 3 and 5. But if we connect it here and here, we can't raise it up because the lengths would have to be longer. So from here to here is 8 feet, so we need a length longer than 8 feet from the other 2 sides to make a triangle. Next, can more than one triangle be drawn with the following conditions? A, side lengths of 5 inches and 6 inches with an angle of 45 degrees. So you'll see here they drew a 5-inch side, a 6-inch side, with a 45-degree angle. Now to complete the triangle, they connect the 2 ends. So we're wondering, is there a different triangle we could make? Well, the problem is, if we made this one longer, then it's no longer 5 inches. Same with this side. And if we tried to drag this out this way, then we would no longer have the 45-degree angle. So in this case, only one triangle can be drawn with these given measures. Down here, it says a side length of 6 inches with angles at each end measuring 40 and 60 degrees. So here we have our side with 6 inches, our 40-degree angle and 60-degree angle. To make the triangle, we extend the lines to intersect. Well, again, if we take this point and we try to move it around, we start either changing the angles, or that's basically it. We would change one of the angles, so these measures would change. So, given these specific measures, we can only draw this one triangle. Okay, our next example, can more than one triangle be drawn using 2 side lengths of 6 units and 9 units and a 40-degree angle that is not formed by their intersection? You'll also see that as a non-included angle. So what that means basically is that 40-degree angle is not in between the 6 units and 9 units. So if we look at this first example, we see one side that's 9 units, one side that's 6 units, and a non-included angle that's 40 degrees. What we're wanting to know is, can we draw another triangle with these same measures that is different from this one? If we look at this next example right here, you'll see that you can take this line, AB, and you could actually keep the same length of it and swing it in to a different point. Then we would still have our line of 6 units, we'd still have our other line of 9 units, and then we would have an unincluded angle of 40 degrees. So this triangle meets these conditions as well as this triangle. So we would say yes, more than one triangle can be made with the given measures. Okay, our last example, is there a unique triangle with angle measures of 30 degrees, 60 degrees, and 90 degrees? So what this is asking is, can we draw more than one triangle with these measures? If the answer is no, then we have a unique triangle. If the answer is yes, then we don't have a unique triangle. So this first one right here, it has these given conditions, 30, 60, and 90 degrees. Well, we could extend these sides without changing the angle. All right, so for example, even if I just pull this and put it closer to the screen, it'll appear bigger, but the angles stay the same. See that? It looks bigger to you now, but the angles are still the same. So in this case, we would say there is not one unique triangle with angle measures of 30 degrees, 60 degrees, and 90 degrees. Okay, for your guys' assignment today in this section, we really have to be careful about reading the conditions that it gives us and testing things out. Okay, if you cannot make more than one triangle from a given condition, then that's a unique triangle. Okay, sometimes we can only make one triangle, sometimes we can make many triangles with conditions. All right, we just need to logic it out. Okay, make drawings, try different things out, and you will come to your answer. If you have any questions or anything like that, please let me know. I'll be glad to help you.